The topic I would like to share with you today is very exciting. So those are web proofs. Have anybody heard about web proofs before? Almost nobody. zkTLS, multi-party computations. Okay, excellent. So there is a few folks here that already know what's going on. Okay, so web proof is one of the most exciting technologies, and we're gonna. So I'm Marek Kirejczyk. I'm CTO of vLayer, and the thing we do is we do verified data infrastructure. So we're gonna deliver more data on the blockchain, and we're gonna write a comprehensive 3-part report about it. And I'm gonna give you a sneak peek what's gonna be in the first part, which is gonna be about web proof. So if you wanna get notified, you can go to the link or just do QR code scan and leave your mail, and we're gonna send it over so you get it first. All right. And today we're gonna talk about what the web proofs are, what are the use cases, how does it work under the hood. We're gonna talk a lot about security because web proofs are a very nuanced topic, and we're gonna talk about some protocol designer considerations if we still have time. But first, we're gonna talk about the state of the Ethereum and where we are today. And I think it's in this very intriguing moment. Ethereum is this very intriguing moment because it's more legal than it ever was. We have ETFs in the United States. We have MiCA coming into power on the other side, on our side of the Atlantic. It's more scalable than it ever was. We have L2s finally maturing, getting secure. We have blocks, we have cheap transactions, we have high volumes. And by the way, it's more usable than it ever was. There are great wallets like, I think it's Dymo, like the transaction fees are not there. You can just send USD back and forth. With that, it feels like Revolut, right? So it's a really good place that crypto is best that it has ever been. But somehow it feels something is still missing. And I think what's missing, we're still missing this kind of a mainstream use case. Crypto is still a lot about speculation, a little bit about international transfers, a little bit about art, but mostly about speculation. And it's really hard to justify even today when the prices are not so high, it's really hard to justify market cap with just, being a big casino, crypto being a big casino. And I believe the reason why we didn't find those mainstream use cases, those use cases appealing to the mainstream, is because Web3 is so isolated. Like when you enter the world of Web3, it's isolated island. You need to set up your new unknown identity, and it's all very isolated. But if you look at the Web2, if you look at the internet and your mobile phone, it's so heavily intertwined with your life. You play games, you read news, you watch shows, you do shopping, you order your taxi, so on and so forth, right? So why can't we just, take some of that things to the Web3? Well, it turns out we're just lacking the technology. Like we would like to get some of this data that is closely related to our lives, but we can't because the Web2 is, it's in the cloud, it's all private behind the bars, and storing data in the cloud is basically for free, like gigabyte of data. Storage is nothing. When on the blockchain, it's crazy expensive. Everything is public. How do we combine one with the other, right? And then maybe the question arises for those of you who've been in the world of Web3 a little bit longer, can we really solve the problem with more technology and cryptography? And I believe the answer is yes, we can. So, verifiable data, there are three main types of verifiable data. There's more other sources that we can look at, but the most interesting ones are web proofs related to web pages. There are storage proofs related to history on the blockchain, or also cross-blockchain, getting data across the blockchains, and email proofs related to the emails. And as I said before, today we're gonna talk about web proofs. So what's a web proof? I'm going to start with an example of the use cases to make it very tangible for you. So imagine real-world asset, right? Real-world asset are those tokens that reflect some real-life value. in the world. So that might be that might be a stable coin, that might be a security like a share or stock in the company, or bonds or whatever else, or it can be even like a tokenized real life object like a car, a real estate piece, or yacht. So there are many options, and real world assets are the fastest growing subspace in the blockchain today. The problem with real world assets is there is some issuer like an asset manager, and he says, okay, this is 3 billion USDT, or I have this real estate, but there is really not much more than just his word for it. And he can of course share screenshots from the documents, from his bank account, but that's easy to forge, and so on and so forth. Is the sound alright? I feel like it's on and off a little bit. Is it okay? Okay. And also like that a little bit. Okay. Maybe I'll try it like that or something. All right. So with web proofs, you could do following flow. You want to issue a token, we'd call it a quackle, and you want to generate a bunch of quackles. And before you can issue a transaction that's going to issue a token, you need to hit generate proof of funds. You jump into the bank. There is a special plugin, browser plugin in your browser that you need to install ahead of time, and it's gonna bring you this sexy sidebar here, and it's gonna tell you, the sidebar gonna tell you, go to this, go to there. And when you're in the right place, there is a amount that you're interested in. It's gonna show up the generate proof. You hit the proof, you hit the generate proof, the proof gets generated, and you go back to the application, and now you can submit the transaction, and the amount that's going to be issued is going to be the amount you have in the bank. Of course, that only helps at the beginning. You can say, okay, I'm issuing 2 million quackles, right? But maybe tomorrow I'm going to transfer that away. So you still need some kind of health checks, periodic health checks, and it's never going to be fully permissionless. But we can push it like ERC20 tokens, right? But we can push it way closer to being trust minimized from where it is today, which is there is no significant mechanism of trust at all. And so this is very. I hope this was very tangible example for you. I'm gonna show one more example, very different. So this is, we believe there's gonna be a new category of apps that's gonna happen in upcoming months and years. And we call it Web2, Web3 markets. I don't think it has a name yet, but people are already talking about it and people trying to build it. So the idea for the Web2, Web3 market is that you have a market that you operate on-chain, but you are trading things on the Web2. You're trading, again, either assets, securities, or could be virtual objects like game items, or could be things that get notarized in the real world, like real estate. So how such a flow, and one interesting example, one interesting case is on-ramp. So you can trade fiat currencies, say US dollars, or USDC, let's say, tokens, right? And in this way, you can build an on-ramp. So how does it work? You go to your favorite on-ramp XYZ, you decide to swap $200 for 200 USDC, and there's this, you need to pick the bank you're gonna be using to generate your proof. You go to the bank, the sidebar shows up, and it tells you to go there, do the transfer, and when the transfer is complete, you go to the transfer page and you generate a proof. I did send $200 to this specific account, and here's a proof. And with that proof, you go back to the application, and the application recognizes the proof, and you can hit claim, and the USDC tokens can be transferred to you in the next transaction. Does that make sense? All right. Questions? No questions. Easy peasy. Good. So there is a little bit of a nuance around how we fetch this data, because it's not a public API that we're using. It's usually guarded behind login and password or some kind of authentication tokens. So we need to get a little bit creative. You've seen an example with a plugin. So the plugin that you install into your web browser. Ethereum is already very successful in putting plugins into your browsers, unlike anything ever before. So we believe that's going to be a good start. We believe eventually, as technology matures, it's going to get integrated into the wallets. So you ain't going to even see it. You don't even you won't even need to think about it. There are some companies that try to do it on mobile. I'm personally a little bit skeptical about mobile because we didn't see any web plugins really taking off on mobile. And there are applications that serves as the browser and you need to go to a website and log in. I didn't see anything successful like that. So there are some companies building prototypes like that. I'm not very bullish on that one, but we'll see how it works out. But I do think there is one more way you can do that kind of gets overlooked by wider zk cryptographic community that is kind of exploring those ideas. It's server, like a lot of health checks. You don't want to go every day to your bank and log in and so on, which is annoying. So probably it's going to get automated. You're going to leave your credential on your server, and it's going to do those automatic checks for you. And there's been an explosion of ideas. I don't know how much of you are big on the crypto Twitter, but last week there was a tweet from Vitalik, 2 other guys. Each 3 of the tweets went viral, and people start discussing all the ideas of the things you can do with Web3. So that brings us to the very essential question: how does that all work at all? So we need to take a step back and look at the thing called TLS connection. As probably the vast majority of you here know, TLS connection is just an encrypted connection, and it's pretty much every single connection you do on the internet to your bank, web, gaming, and whatever else is probably encrypted with the TLS protocol. And it's, the HTTPS, the S stands for TLS. So probably any data that exists in the world is behind some kind of TLS connection. And just to agree on the naming, there is client and server, like an TCP IP connection, and the content they exchange between each other we call transcript. So idea of the web proof is that we take this transcript and we can somehow stamp it, somehow we can authenticate its origin and make sure it's not tampered with, and send it to verifier, and the verifier can grab it in hand and be sure that happened between this client and the server, and based on that do something, right? So that turns out to be extremely difficult problem to solve from the cryptographic standpoint, and it took years for very good teams to get to the working solution, partially because TLS was updated a few times, so every time they got near to the solution, they kind of have to redo it. But the essential problem is that TLS connection is using symmetric encryption, which means it's indistinguishable if content was produced by the server or by the client. So usually we want to prove that server sends something like, hey bank, what's my balance? $2 million. So if client can produce it, then obviously he can say, yeah, my balance is $20 million, right? So, well, that sucks, but it turns out there is a very interesting, sophisticated solution that introduces multi-party computations. And the way it works is you introduce this new role in the system called notary. So the notary is a server that the client gonna connect to. So he's gonna connect to the original server and additionally to the notary. And notary gonna be taking part in the connection. And the way it takes part is half of the encryption happens on client and half of the encryption happens on notary. And there are very clever algorithms that make it so that only the two together can make a full connection. If one of them is in any way malicious and is not conforming to the protocol, what happens is the verification fails, right? So the client and the notary need to collaborate together to work, to connect to the server, exchange information, produce a transcript. Each of them is transmitting half encrypted transcript to the verifier, which can combine the two into the actual transcript. Does that make sense? Is that easy? See, you're already getting better in cryptography. Good. So that's pretty cool. That's kind of working. There is a great team called TLS Notary. They are part of PSC team, so privacy and scalability exploration. So that's a kind of a foundation related to Ethereum Foundation, and they created this TLS notary that works like I explained here as a public good project. So it's open source, they keep updating it. It's a great, very clever team. But that's where the TLS story ends. But that's not where our story ends. So how do we take those web proofs and put them on the blockchain? Well, why don't we just run verifier on the blockchain, right? Why can't just smart contract be a piece of code that runs verification? Well, unfortunately, it turns out that verification is very computational expensive thing, and we won't be able to run it on blockchain or layer 2 or even layer 3 anytime soon. Yeah, so that sucks. So let's explore. So that's the problem. Let's explore solutions. So there are 5 solutions I want to talk about today. I don't think we're going to go in details on every single one, but I just want to show you the map of what's possible, of the kind of the road ahead. So I'm going to start with a naive solution. So the naive solution is, since verifier is already convinced, he can just add a signature and say, hey, I'm vouching. I'm telling you this is good stuff, and I can send it to the blockchain. Can anybody see an issue with that? What's the issue, sir? Centralization. So the verifier can sign now on anything, and he can issue any action he wishes on the blockchain. This is not what we fight it for, right? So yeah, that's a dumb idea. By the way, that's how every single project who combines TLS notary that I'm aware of is working. That doesn't mean, they're dumb projects or anything. We're just very early. Those web proofs that kind of started working very recently, and people start to figure out how to use them on the blockchain. So yeah, the single point of failure. So actually, if you ever drill down, they're usually gonna tell you you need to trust notary, not verifier. So the naming who's notary, who's verifier is a little bit fuzzy, but you get the drill. It's the single point of failure. And yeah, so that's funny. We came up with this solution by accident. How about if you run a verifier and in the zk prover, right? So who knows what zk proofs are? Okay, so zk proofs, in just 3 sentences, we can agree on the algorithm upfront, and this is the program, and I can run the program. It can be very complicated program, can be run for hours, and at the end, I get a result and a proof that the result was actually produced by the program, and that's how zk rollups works, right? So just for the people who's gonna watch it on the YouTube, around half of the people in the room knew what the zk proofs are, so I thought it's gonna be important to explain it. So this is how the zk rollups work. They keep calculating the transition function between every transaction, every block, and keep proving that everything was correctly calculated. Yeah, so with zk proofs, we can prove that the verifier was honest, and this can be translated to, this can be taken to the blockchain and verified on the blockchain now. So we're gonna have 2 verifiers, TLS notary verifier and the smart contract verifier that's gonna verify zk proofs, right? So we have now 2 proofs, web proof and zk proof. But I'm gonna clarify that. So the nice thing about that is, since we're already writing the zk prover, we can add some computation to that, because if you think about it, you get your JSON from your API. Do I want to parse it on the smart contract? Probably not. So we can use zk computations inside the verifier in the zk prover, in the TLS notary verifier, so zk prover, and find in JSON wherever we want to find, and just flash those straight to the blockchain. So that already have pretty interesting security properties, because it kind of translates the original properties of TLS notary to the blockchain. So one thing, and I'm gonna start with the second point here. So we now getting kind of a multi-sig 2 out of 2. So the client and the notary need to collaborate together to get this proof. They cannot do it alone. So from the user perspective, from the protocol user, the one who's interacting with the blockchain, doing stuff with the blockchain, it's already pretty nice property, because now the malicious real-world asset manager cannot print fake tokens without notary helping him, right? And vice versa, the notary cannot do anything. But even more interestingly, the client don't need to trust the notary. So imagine there is a notary and a bunch of different real-world asset managers, and one day notary get hacked. Then nothing can happen without those clients. So the clients are safe against the notary, right? So we already arriving at much better security properties, which, it's not perfect, but it's already so much better than trusting a centralized property. So that's especially reasonable for real-world asset scenario. Probably not so good for the Web2, Web3 market, because in scenario with real-world assets, we know who the asset manager is, right? But in case of Web2, Web3 market, anyone can be a client, so notary can just spawn a bunch of clients and attack your protocol. Good. Everything makes sense so far? Any questions? Wow, everybody. A lot of people are nodding yes. I think that means some of them really understand what I'm talking about. Good. So one interesting, and this is what cryptographic community around blockchain is talking about a lot for a few months now, is how about we use hardware enclaves or trusted execution environments. So this is the idea. So one of those was SGX. It was introduced by Intel, and it's an environment where you can run some executions. Everything is encrypted inside of there, and they have a hardware keys that are in the silicon that are very hard to retrieve from the silicon, right? So that's pretty cool. With that, we can run a notary in trusted execution environment and a verifier, which makes it really, which makes it even more safe, because now client cannot collaborate with a notary without breaking the trusted execution environment, because everything that happens in the notary is encrypted and it's pre-agreed algorithm. A notary can sign on it and say, this was the notary, the trusted execution environment can sign with his private silicon key saying, this result is result of execution of pre-agreed program that was run in an encrypted environment that the user didn't have access to, right? So that's pretty cool. That we solved the problem finally, didn't we? Yeah, except TEs get hacked all the time, and it feels like there's at least one major hack every year. So I gave this presentation just yesterday on Verifiable Summit, and I said there was not a single hack that led to leaking of the hardware key in silicon. And someone came to me after presentation and said, this hack that happened 3 weeks ago, they actually extracted hardware keys from the silicon. And also something to keep in mind, there are very expensive techniques like scanning electron microscopy or focus ion beams. So those are techniques available to state actors or advanced kind of agencies. And that kind of can get anything from the silicon, right? So those are expensive, unlikely to be in the hands of attacker, but the risk here is if webproof is gonna become very successful, eventually some state actor, like Lazarus Group, could take advantage of it. So also in this first variant, we run TE on notary and verifier. So it seems we can prove of that by running verifier in the zk and notary in TE. So that's increasing security a little bit, because now client needs to collect the notary, and he also needs to break get the TE hacked, right? So it's getting harder and harder. Yeah. So that could be an interesting solution. One thing to know about trusted execution environment, they require maintenance, right? So things get hacked. Usually the things get hacked are not the most recent version of the enclave, but a little bit older. When things get hacked, you can apply a software update to the hardware enclave. When that happens, you need to make sure that the enclave is reporting and signing on the fact that the upgrade was applied. So it seems like with a little bit of maintenance, that's a nice direction to go to. And I think it's a good time to introduce the concept of black swan event. So when you design your protocol that is using web proofs, then the big question you want to ask yourself, is there a black swan event? Can there be like, can I generate 1,000 users and each gonna generate a web proof, fake web proof, and that's gonna drain my liquidity? Or is there some limitations that allows you to, when the attack happens, to mitigate the results and making sure that the protocols can go on? So we're now getting into this space where when we see how nuanced it is, and it really depends on our protocol and what are the different solutions that we use to make a secure protocols. And I think it's worth mentioning because we're using multi-party computations, but it's also called 2PC, two-party computations, client and the notary. But what if we increase the number of notaries to 2? So then we have 3-party computations, a client, 2 notaries, right? So that is technically possible. It requires major upgrades to the TLS notary protocol or whatever else is available today. One thing important to understand is that there is a giant overhead that MPC have. So it's a 3 orders of magnitude. So if you're exchanging 1 kilobyte between client and the server, then the notary and the client are exchanging a megabyte of data. So you can see the limitation. So the TLS notary team is working on speeding that up, pushing that down to 2 order of magnitudes, which is order of magnitude improvement. And then when we're gonna go back to 3PC, it's gonna increase it again, right? So it's very, very difficult trade-off. I think I'm running out of time, is that right? All right then. So just gonna sum up. So that's gonna bump 2 out of 2, multi-sig to kind of 3 out of 3. And the nice thing, we can combine it with zk, and we can combine it with 2 different T's. So we're becoming, now the attacker needs to hack 2 different hardware enclaves, needs to collaborate with the client, so on and so forth. So you see where that trajectory goes. We can add more cryptography, we can add more hardware, and make it more secure. And yeah. So there is a bunch of other things I would love to talk to you about. Other crypto economics-based models and other considerations for the protocol designer. So I'm gonna skip on them and just gonna say that web proofs are among the most exciting technologies to transform Ethereum ecosystem and broader blockchain ecosystem. The new exciting use cases are coming. Technology needs time to mature, so don't send billions of dollars tomorrow with TLS notaries or web proofs in general. It's nuance, and protocol design should be aware of those security nuances, and stay tuned for the report if you want to know more. Thank you very much. Do we have a time for one question?
Let's do one question.
One question then.
Has to be a good one.
Damian, we're counting on you.
So there is a case with 2 of 2 multi-sig for notary and the client, and 3 of 3. Can you make it 2 of n? At this moment, like if one notary is down, then the whole...
No, not really. Because of well, you can pick 2 out of n for the connection, but once the connection starts, you cannot swap, and you can't really add a third one because it's gonna be like, 4 or 5 orders of magnitudes overhead. So now you're gonna exchange gigabyte to verify kilobyte.
Sure. So now you can like choose 2 of n, but when the connection starts, you have to keep this one notary for the whole connection.
Yeah. Okay. But so now the only thing available is a single notary. It's gonna be a major upgrade to the protocol to make it 2. That's maybe a year ahead, and so that's important to understand that we need time for this technology to mature. But any solutions we've seen based on randomness and building a group of notaries that are very nuanced and not leading to a simple solutions. So that's something to keep in mind as well.
So just to sum up, currently you can select only one, but can you select any from a list?
You can select You connect to the IP you like the best.
Okay, thank you.
Thank you.